Okay, so today we're going to compose functions, okay? We're going to do composite functions where, unlike evaluating where we plug in a number and we end up with a number at the end, we're going to end up with a brand new function, okay? So we got to think back to what is a composite function. It's whenever the output of one function becomes the input of another, right? But now we're not going to have any output of one function. It's just going to be that function plugged into another function. I'll show you what I mean. Let's look at, for the next few examples, we're going to use f of x is x squared minus 1, g of x is 3x plus 3, and h of x is 2x to the and h of x is 2x to the negative 1. Now, let's do f of g of x. Okay? So f of g of x. The first step that I'm going to do is I'm going to replace g of x with 3x plus 3. Because that's what g of x equals. Okay? So I wrote replace g of x. You could also say like plug in g of x. Now, let's look at what this says. F of 3x plus 3. So instead of f of x, everywhere that there's an x in the function, now there's going to be a 3x plus 3. So every x in f becomes a 3x plus 3, right? So we're replacing every x with that function g. So I have equals, it used to be x squared minus 1. But now what's being squared? 3x plus 3. Okay, now to evaluate that, I'm going to have to actually square that. So that's 3x plus 3 times 3x plus 3 minus 1. We FOIL that out because it's a binomial here. So 3x times 3x is 9x squared plus 9x, another 9x, plus 9 minus 1. We have f of g of x is equal to 9x squared plus 18x plus 8. Now I have to think, okay, what's the implied domain here? For implied domain, I check two things. Do I have any square root symbols in this, or any roots at all? No. Do I have, am I dividing by x at any time? No. If neither of those things are happening, the domain is all real numbers. All right, now let's look at these next two examples, which these are just all different ways that I can write composition of functions. This h of g, this hog thing that we have, this just means h of g of x. So, the very first thing I'm going to do is I'm going to figure out what this g of x is. Okay? So it's h of g of x is 3x plus 3. Now, this function is just going to get plugged into which function up there? This gets plugged into h, and for the x. Okay? So this is the same thing as, bust out the green here, 2 times something to the negative 1. And that something is 3x plus 3. Okay, so here we have an interesting case because this 3x plus 3 is being raised to the negative 1. So we have equals 2 over 3x plus 3. That being raised to the negative 1, let me know that it needed to be moved to the denominator. Right? That's what negative exponents do. They're in the wrong spot. Now, I have to check, is there any, I could factor out a 3 here, that would leave me with an x plus 1, but does that cancel anything with this 2?
No.
No. So, factoring won't help me at all. Right?
Right.
So I need to, I'm done. This is, I couldn't figure out, I was like, what's that word for I'm finished? All right, so h of g of x equals 2 over 3x plus 3. Okay, but now I have to think about my domain. There's no roots, but there's an x in the denominator. Okay, so x in the denominator is not a cool thing because what number can we not divide by?
0.
We cannot divide by 0. So I know that whatever this 3x plus 3 is, it cannot be equal to 0. So I set the entire denominator equal to 0 and say, okay, you cannot be 0. And now I'm going to solve for x. So 3x equals negative 3. Divide both sides by 3, and x cannot equal negative 1. Okay, and think about that. 3 times negative 1 is negative 3, plus 3 is 0. So if you were to plug a negative 1 into this denominator, you would get 0 in the denominator, which you cannot have. So my domain is all the real numbers except negative 1. Sometimes with function composition, if you're not evaluating, you might see it written as just like g of g. And that's the same thing as writing g of x. Okay? So my first step is I'm going to replace that inside g of x with what g of x is, 3x plus 3. Now this time we have g of x. So we take g of x, this entire 3x plus 3, and we replace the x in g of x with that. So this 3x plus 3 is now going to replace the x in g of x again. So we have 3 times 3x plus 3 plus 3. So I distribute the 3, I get 9x plus 9 plus 3. So g of x is equal to 9x plus 12. Okay, now am I taking any roots, or is x is x in the denominator? No, neither of those things are affecting my domain. So what's my domain?
All real numbers.
All real numbers. All right, in our last two examples, we have f of g of x. So f of g of x is equal to f of, now we have new functions, so I'm going to replace this with my new g, x minus 1. So now all of the x's in f get replaced with x minus 1. So this is equal to the square root of 2 times, all the x's are replaced with x minus 1 plus 3. Okay. So that's the square root. The 2 gets distributed across the binomial, so 2x minus 2 plus 3. So f of g of x is equal to the square root of 2x plus 1. Okay, now let's think about the domain here for a second. The domain. Do I have an even root here?
Yes.
Yeah, this is a square root. So I know that I cannot take the square root of a negative number. Right? The square root right here. I cannot take this, whatever's inside, I cannot get a negative number. So whatever this 2x plus 1 is, right? I need to make sure that that is greater than or equal to 0. Anytime we see a root, and if there's an x inside, we know that it needs to be greater than or equal to 0. So subtract 1, 2x is greater than or equal to 1. Oh, I'm sorry, negative 1. Divide by 2, and I see x is greater than or equal to negative 1/2. Okay, so x is greater than or equal to negative 1/2. That's the domain of this function. Alright, here's a graph of that, of the square root of 2x plus 1, just because I want you to understand this domain, okay? We set what was underneath the square root greater than or equal to 0. And we solved and we said that, okay, the domain must be greater than or equal to negative 1/2. And look at this graph. All of the x's are greater than or equal to negative 1/2. Okay? So these things make sense graphically as well. Alright, our last example, h of f. So this is h of f of x. So the first thing I'm going to do is replace that f of x with the function f of x. The square root of 2x plus 3. So now this x and h is going to get replaced with a square root of 2x plus 3. So now I have that this is equal to, it used to be an x squared minus 3, but inside this is now square root of 2x plus 3. Now what's the square root of 2x plus 3 squared? We don't have to FOIL anything because it's not a binomial. It's all underneath the square root, so it's just 2x plus 3. And then we still have this minus 3 on the outside. So h of f is just 2x. 2x is just a line. There's no asymptotes because there's no dividing by x. There's no roots. So my domain is all real numbers. Okay, so the big picture is you just take one function and plug it into a different function. Okay? All right, that's all we're going to do.